Alright, time for another DraftPhysics.com video presentation. So, little Johnny Walker has posted a comment, just kind of funny, because he put a lot of effort into this contrived pile of mush, and we'll see if Michael responds to it. We've talked about this before. It's the free momentum idea, that somehow the more of a reflection you get, the more energy you put into the object you hit. So somehow throwing a rubber ball versus a steel ball at a wall will somehow produce more momentum, more energy in the object, which doesn't make much sense. Doesn't make any. Okay. Hello, Michael. I made a slide and descriptive text about the ball bearing bounce up and down on the anvil. So it works with anvils or it works just with pendulums. It doesn't really matter. I mean, it's this idea, okay, that the more bounce back you get, somehow the more energy you put into the object, when it seems kind of obvious that the less the object moves, the firmer the wall, the more energy you get back. The less energy you put into the wall, the less it yields, the more the bounce back. That seems the obvious truth. It's sort of visualized like, say, a car. Your car's moving and you throw a rubber ball. The rubber ball will bounce back with the motion of the car plus the motion of the ball. It'll come back with more energy because it will absorb energy from the object moving. Twice the energy doesn't go into the car. Okay. This was because Goofy's bizarre idea that momentum will pile up after each bounce. Well, it's not my idea, it's your math. Okay, this misunderstanding, the math says so. So, comes probably from the collision experiment where the cart collides with the way heavier not moving cart. Yes, the one not moving, which means it didn't absorb any momentum. That will get 200% of the momentum. Yes, but it can't. Okay. Of the first cart, that, by the way, gets minus 100%. So whatever the game is there. Of the original momentum, such that the total momentum remains conserved. And it only remains conserved if you do this subtracting an idea of momentum, that somehow it matters what direction it's going. So in the simple lever experiment that physicist Michael did, where he put energy in this way and he got energy out this way, the argument is that somehow he lost all the momentum. Say if you did it perfectly, it would mean you destroyed the momentum because you have a plus and a minus and it equals 0. So that doesn't make any sense. You can download the two things. The original momentum You can download the two things so they can save you some time if you want to make a video about the problem. Maybe use my slide in your video. Take care. So these are slides he made. So one of them is a big pile of writing, and basically what he's arguing is that the gravity of the little ball bearing, which is 10 to the minus 600 times smaller than the energy of the ball bearing's bounce, the hit, somehow that gravity pushes the Earth back the opposite direction. So instead of the Earth continuing to move in the direction that the ball hit, the Earth, I'll draw it, somehow moved back up because it was pulled towards the ball bearing by the ball bearing's incredibly strong gravity. So it's just a made-up, silly answer, but it just remains a curiosity that all of you understand this part of physics that is, in my opinion, just too ridiculous. So the argument is you have the anvil on the Earth, okay, and what was found is that the anvil, the reason why it bounces, okay, so many times is just because of the fact that you can make an anvil in different ways. You can heat treat it or not heat treat it. So you don't heat treat it, what happens is the surface does actually dent. And so we know that the energy gets used up by deformation. So you only get like 4 bounces and that's it. And then you get 200 bounces, okay, if you heat treat it, okay, because it doesn't dent. The surface is impervious, okay, to denting. And so the ball just keeps bouncing because it doesn't deform any of the metal. So the same amount of vibrations, you could argue, blah, 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 all this other crap. And really the key difference is you're either moving atoms or you don't move atoms. If you don't move anything, then you get all your energy back. If you move something, you lose it. And it's really that simple. You can't give something momentum unless you move it. It's just a fact. So anyway, for this experiment, they're basically making the argument that the impervious anvil is just part of the Earth and that the Earth itself will actually move. So when the little ball bearing hits the metal, that the whole Earth moves. Yeah, that's what they're arguing. And you get a bounce, a complete bounce all the way back up. So the more the Earth moves, the more the ball bearing bounces back up. So it's completely the opposite of the idea of throwing something against a brick wall and having the expectation that the wall doesn't move and then you get all the energy back. But if the wall does move, whatever amount it moves means you'll get less coming back. So the more the wall moves, the less bounce I get. The less the wall moves, the more bounce I get. Their math says exactly the opposite. And so that's the curiosity, because obviously you could say, yes, if it continues to keep bouncing and each time it's putting this arrow of direction in. Now he's saying, okay, that somehow that happens the first time, but he's saying when the ball goes back up, the ball's little tiny gravitational field, okay, the little tiny bit of gravity it's producing that's making the Earth fall towards it, is strong enough to stop the Earth from moving this way and actually forces the Earth to go back this way so that the Earth doesn't keep going. So if I just let it bounce once and I grab the ball, right, and I hold it in that position because it's going to pack up, the Earth stopped moving. So the Earth moved and then it stopped because the ball went back up and it's now pulled the whole Earth back. So yes, the fact is this gravity is, 10 times 10 to the minus whatever, 35 or something. 35. Tiny, tiny force. Okay. And so, yes, the joules of this force is billions of times smaller than the force of the ball hitting. So that force is gigantic by comparison. It's the Earth to the size of a ball bearing. I mean, it's a gigantic disproportion. And so is the energy. This creates essentially no gravitational influence on the Earth. It can't make the Earth move. So it's just stupid. So let's do the straight across example of just moving the cart and just point that out, because that's the one that's easier to illustrate and certainly don't have to measure whether the Earth moved to make the argument that it's free energy. But the fact is the simple argument is that no, you won't be able to take away the Earth's movement once you gave the Earth momentum, and that every single time the ball bounces, it's just going to add more energy. It's a new experiment. Each time is a new experiment. It's going to just keep pushing on the Earth. The Earth is going to get 50 or 60 times the energy you started with. So you started with a little bit of energy, momentum, and inside the Earth you're going to have 60 or 70 times that momentum, because you're going to just keep doing the same experiment over and over again. Alright, so here's the simple rundown. What they say happens. So we have a simple Newton's cradle. We're just going to collide a same mass into a same mass, and we're going to transfer the energy. All of the energy will go from this object into this object, so we'll have zero coming back, zero reflection, and 100% of the momentum will go that way, and it's pretty simple. So I just put a couple of fleas on top of this ball. I make it a little tiny bit heavier. So let's just say it's 10% just for the hell of it. Anyway, do the same exact thing. Always 100 in. Always 100 in. Okay, so I put 100 in. Their argument is, their math says I put 110% into the object. So even though it's heavier, it's going to get more momentum than I started with. And I'm going to get a reflection of that 10%. So I'm going to get 10% back, plus I added 10% extra to this. So I gain 20% total momentum, you could argue. Now, obviously, I would argue that Newton and me, or Descartes and me, or Galileo and me, would say that no, that's not going to happen. What you're going to do is put 90% into this object. You're not going to get all the momentum in because it's not going to go fast enough. It's too heavy. I can't do the conversion. I can't take all the energy from this and just smoothly put it into this because it can't do the conversion. So 10% of it's not going to go in. I'm not going to get the full velocity. I'm going to get something less than. And proportional to the amount of the mass. So the velocity will go down because it's heavier and I can't transfer the full velocity into the object because it's bigger than my velocity will allow. So I can't get the energy in. And so this number will be 90, not 110. And 10% will come back. And in this case, it's even bigger. So now I'm going to get 30% reflection and 30 extra into the object. Well, I'm not going to do that. It's going to be 70%. It's going to be going much slower now. And then eventually I'm going to get 70% back as a reflection. And this is going to absorb even less. And now we're down to 30% got absorbed by the wall. And eventually you get it heavy enough where it doesn't move. They say 200 momentum going in. I obviously say 0 did. And that's why I get all of it back. Is because none of the energy was transferred. And all I got was a reflection back. So they say this happens. Now you can build you could build a device of sorts that will illustrate how this circumstance doesn't make any sense, okay, and that it would be a, I don't know, an earth mover, whatever. All you have to do is have the object move just a little bit, that 99. So instead of 100%, you just make it 99. And so you just have a pendulum attached to a ball, and you just have your object here, and you swing this in. This is massive. It weighs more. So it's mass plus. You could just argue it's very massive. But it can move. So it will absorb a little. It'll do a little tiny bit of moving, which means it will absorb all the energy and it doesn't go into the earth. So we don't have the earth excuse. So this is an anvil essentially, and this is your ball bearing. So it comes in with your 100 momentum. And the argument is that their math says it hits. This does actually move, okay, with 199. All right. And this bounces back with 99. So I got almost all the energy back, and I moved this. And now it's going to swing in and hit again with 99. So now it's going to hit with 99. This is already moving, but it's not moving very fast because it's much heavier. So I can still hit it again because it hasn't really escaped. It's moving so slowly. And so I'm going to hit it again. And I'm going to give it another 199. But again, it's much heavier, so it's moving away very slowly. This will bounce back, and it'll come back down again, and I'll put another 98 into it. And so this got 199, 198, okay, and then it's going to get 197, and then it's going to get 196, and it's just going to keep adding up, and eventually that's going to be a real velocity. All right, but it's going to get all of these momentums. Each time this comes down and hits, it's going to add this number to its velocity, this big, giant, huge number. And so this is going to end up with, 2,000 joules of momentum, you could argue, right? And you only started with 10, kind of thing. You're going to end up with a huge increase in your momentum, because you were able to keep using the same energy over and over again and give it to this object. And there's just no way to get around that paradox. It is what the math says, and it's just plainly illogical and nonsensical and stupid. Yeah, and dumb and not real, and it doesn't happen, and it's just not true. So I don't know what else needs to be said. It's just not good physics. And I don't know why that you would waste time trying to contrive a reason to believe that, the more momentum you put into a surface, the more reflection you get. When everything about reality says the less momentum you put into the surface, the more reflection you get. It's that simple. The counter argument is that simple.